Hello. Hi everyone. Myself Orko Jyotide. And in this video, we are going to solve the first question of Lead Code Contest 432, that is Zigzag Grid Traversal with Skip. So it is a easy level question, and I don't think we will need much time to solve the question. So you are given a m cross n 2D array grid of positive integers. So first thing to note is we have been given positive integers. Okay. Our task is to traverse the grid in a zigzag pattern while skipping every alternate cell. So how we need to traverse, it is given uh, in the actions right below. You have to note that you must skip every alternate node during traversal and return the result in order in a list, right? So if I would like to if I would like to able to visualize you the question, you have been given a grid, 2D grid, right? Okay, a 2D grid you have been given, and what they are saying that you need to store the numbers that are present in the grid in alternate manner in a zigzag pattern. Suppose this is my row number 0, 1, 2, and 3, and this is my column numbers 0, 1, 2, 3, 4, 5. Okay, so first we will take this one, then we will skip this one because we are going to take the alternate ones, right? Second, we are going to take this, we're going to skip this, we're going to take this, we're going to skip this. And after traversing from left to right, we are going to traverse from right to left, because when we have gone like this, then we are going to go like this for the next row, right? So we have skipped this, and when we will encounter this one, we will take this because we have taken 0 comma 4 grid. We have not taken 0 comma 5, and we will take 1 comma 5. We will leave this, we will take this, we will leave this, we will take this, we will leave this, we will take this, we will leave this, and likewise we will have the list ready with us. So how can we think to implement this logic? So one thing you can observe that uh, see, when we are going from left to right, we are going from left to right in when the row numbers are even, and we are going from right to left when the row numbers are odd. So this is the first observation you need to do. Next, okay, we can traverse from left to right and right to left by considering that what is our row number. If it is even, then we will traverse from left to right, and if it is odd, we will traverse from right to left. But the thing is, how will you able to add the alternate positions? There you can have one thing, you can have a variable as position equals to 1. For the first time we will take it, and as soon as we will add it, every time we are traversing, we will increment position by 1. And when, see, here position is 1, here position is 2, here position is 3, here position is 4. Whenever the value of our position is odd, we are going to add the numbers present in those cells. And likewise, we can easily implement this code. If I would like to show you the code that I have done, it's here. See, first of all, I've been given this function already written by lead code. I have written a small function f, a helper function that will, I will pass the grid in there, and it will calculate me, it will return me the list, and that I will return from this main function, right? So mm, see, this is my helper function private, and it will return a array list of integers. And I have created this because I don't want to write every time the whole word grid every time. So I have taken it as G. N represents the number of columns, and M represents the number of, sorry, N represents the number of columns, and M represents the number of rows. Sorry, M is the number of columns and N is the number of rows. P, as I have already shown you, P is the position. I have declared a new array list that is empty right now. And now I am going to traverse each and every row, row 0 to n, and increment row by 1 every time. For the first time, when row is divisible by 2, we are going from left to right. So column is equals to 0 to m and incrementing it by 1. And when it is not divisible by 2, then we are going from right to left, right to left, yeah. M minus 1 to 0, and c is equals to c minus 1. And here you can see, if p modulus 2, if the position is odd, then we are going to add the element that is present in the cell. And next time we are incrementing position by 1. And here also same, if it is odd, then we are adding uh, the element, and we're incrementing the position by 1. You can do one thing also, like, no, you have to increment it here only. Okay, next I am returning my list to the main function. Sorry, not the main function, the function that will return the list here, list of integers. So this has been accepted, and now let me check that. See, this is the accepted, like the accepted terminal, and here, uh, if we will talk now about the time and space complexity. So what is the time complexity? So here you can see, talk about the time complexity, it is big of n cross m, number of rows into number of columns. Why? Because we are traversing each and every cell in the grid or the matrix, and we are checking that if it is a alternate position or not. If it is a alternate position, then we are adding it on your list, and if it is not, then we are not adding it. The next thing, what is the space complexity? So here in the question, it is already told that you have to return. So here it has been already told that you have to return a array list. So considering, we will if I will consider that array list as the space complexity, then we will have a space complexity of n cross m by 2. Why by 2? Because we are just adding the numbers in the alternate positions only. Suppose I have a matrix, like a matrix of 4, I am adding only 2. Matrix of 6, I am adding only 3. Matrix of the number of elements 3 cross 3. So 9 elements, then 1, 2, 3, 4, 5. I'm only adding 5. So it is of n cross m by 2. Okay. Mm. The space complexity. And this is the time and the space complexity. And as the constraints are pretty less, 50 into 50, so it will run fine. And it should, because it is a easy level question. Can we see some other solutions as well? So what have they done? They have used a while loop, if not skip. Okay, they have used flag here, right? No problem. We have used the same logic, but just implement it in some other way. And thank you. Bye bye. Take care.